So basically, you've got this incoming radiation, and some of it can be reflected by clouds, some of it is absorbed by the surface, some of it is reflected or absorbed by gases in the atmosphere, and then, the planet doesn't just take in radiation, it emits it too. And so some of that radiation that's going back out is absorbed by clouds or then emitted back by the clouds back down to the surface. I mean, it's not a simple thing of just the sun shines. There's a lot of things that go into the temperature of a planet, okay? And so this is just like I say, it's a kind of a complicated thing to talk about the greenhouse effect. But over the years, people have given the greenhouse effect kind of a bad name. And the reason that it's gotten a bad name is because some of the pollution that's emitted that is affecting our warming climate, those are called greenhouse gases because they help to trap more heat. And so people all of a sudden think the greenhouse effect is bad. It's not. The greenhouse effect, without it, we wouldn't be alive on this planet. Because I want you to think about Mars. Mars has a very thin atmosphere. Okay? Most of the heat that it gets from the sun, most of the radiation goes right back out. So, on Mars, at night, the temperatures drop down to like 90, 100 below zero. During the day, it barely makes it up to 20 or 30 degrees. So Mars has a very thin atmosphere. It can't hold that heat. Now, at one time, Mars had a thicker atmosphere. It was able to hold more heat. And actually, we think we're starting to get more confident that there was water on Mars at one time. But then the exact opposite of that is the planet Venus. The planet Venus has a very, very thick atmosphere of carbon dioxide, sulfuric acid, it's just droplets. I mean, it's a very hostile place. That thick atmosphere traps so much heat from the sun that the temperature on the surface of Venus is like 800 degrees, I think it is. So the greenhouse effect has a tremendous impact on how much heat the planet can hold. Okay? This is surface temperatures. Okay? Now again, we were talking about from the sun, and they can track. They have some ideas. They know some things that have happened in terms of the sun going back over the past hundreds of thousands of years. And the reason we know this is the Earth goes through certain cycles. Okay, the actual axis of the Earth tilts the other way, and the little changes in the orbit. So they know when those things have happened in the past. So if you look here, these are temperatures going back. Let's see here. I just put this. This is from the year 1000. So we're going back about 1,000 years in this case. Okay. And we're not going back now hundreds of thousands of years. We're just looking at the most recent 1,000 years. And so this is from things like, they still use the ice cores, but they also use tree ring data. And of course, the last 150 years or so, we have thermometers. And again, if you look, there is fluctuation. Temperatures are not linear. I mean, they go up and they go down. Okay? But if you look over the past 1,000 years, and again, this is agreed upon by basically all scientists. You go back 1,000 years, notice, there are ups, there are downs, times it went down, times it went up, and then all of a sudden we get to the Industrial Revolution when we started having industry and putting greenhouse gases in the atmosphere, and you look what happened. Now, you have a forecast here as well, and this comes from the Intergovernmental Panel on Climate Change at the UN. I was actually in Geneva at the UN talking to some of these scientists last March, okay? So again, I don't just sometimes you can just read this stuff. I actually traveled to talk to the source. And I was in Geneva at the IPCC, which is a specialized agency of the United Nations. And I was there in March. And so they have 3 different forecasts. The forecasts are based upon what we do with our greenhouse gases. Do we take, sharp measures now? Do we kind of stay the course? Or do we just kind of let it go? And so this is what they call the optimistic, the balanced, and the pessimistic views on what's going to happen with emissions, with greenhouse gases. And you can see, even in the most optimistic scenario, you can still see the very, very sharp warming that occurs, and then it finally kind of levels off about 100 years from now. Okay? But yeah, you can see from the forecast there that the warming is we're basically past the point now of stopping. If you ever hear, let me tell you something, if you ever hear somebody say we need to do this, we need to vote on this, we need to do this because we need to stop global warming. That's a tune-off right there, because we're now past the point of stopping the warming. Very important.